Prove that root p plus root q is irrational, where p and q are prime numbers. So let me start off with, yes, what is that we have to use? We have to make use of, yes, proof by contradiction. So initially we'll assume that root p and root q are rational. Let's assume to result in rational or rational number. We'll assume that. Okay. So we have therefore root p plus root q is equal to an x. So what is x over here? Where x is rational number. Because we're telling it results in a rational thing. So it can't be write x as a rational number. Yes. X has to be a rational number as per our assumption. Understood? Not complicated. We're just writing it to be a rational number. That's it. And now a bit of rearranging. So root p is equal to x minus root q. And after this, squaring on both ends. Squaring both sides. So what do we end up with? We end up with root p square is equal to x minus root q the whole square. And here we are going to make use of the identity a minus b the whole square, which I'm not going to write. And we have root and square getting cancelled. And so we have p is equal to x square plus root q square minus 2 into x into root of q. And we have root and square getting cancelled. So we have p is equal to x square plus q minus 2x root of q. Okay. And yes, the funda here is to get q square, root of q square, and one of the sides. Since it's negative, I'll transpose that and then transpose this. And we have 2x root q, which is equal to x square plus q minus p. We can't simplify anything over here. All we have to do is root of q is equal to x square plus q minus p, entire thing divided with 2x. This expression has powers to be 1, right? And all of them put together will result in a rational number, while this is irrational. Why is there a contradiction? So this contradiction occurs because of, yes, our wrong assumption. This contradiction. What contradiction are we looking at? Of LHS being an irrational number while or it is rational is because of a wrong assumption. Right, guys? This is a irrational number. Why? Q is a prime number, is it not? Q is a prime number. Root of prime numbers is always what? Irrational. Is it not? Root of 7 is irrational. Root of 13 is irrational. So we have an irrational number being equal to a rational number. How is this possible? How is that we ended up with such scenario? Because our assumption was wrong. And so, therefore, root q plus root p plus root q is irrational. Okay, that would be your answer. Understood? Again, start off with the expression equated to a rational number, rearrange, square and square root and all of that. I hope you guys learned from this. You should have been thorough by now. If not, it's quite simple. I've done it in the basics. Simplify this. Okay, be smart about what you transpose and so on and so forth. Get an expression and just write the conclusion. Very simple question. Aram se 3 marker question. You can get it without any mistakes. You know the answer. All you have to do is take the derivation to that. Okay, yes, you can pause and have a look at the answer.